So why do we do what we do? Let's look at a lab notebook from 1927. This is from an unknown chemist from the Kaiser Wilhelm Society. Let's fast forward to 1985. You have this supercomputer called the Cray 2. It was very, very big. You could barely fit it in a standard sized bedroom. It was prohibitively expensive, so certainly average Joe would not be able to afford it. Only 30 years later, you have the smartphone. Pretty much everyone can afford it. You can fit it in your pocket. And not only was it smaller, was it more affordable, it was also a lot faster than the Cray 2. So in just a short time of 30 years, an astonishing amount of progress was made. If we look at a typical lab notebook from 2023 from the domain of synthetic organic chemistry, in an academic context, you can really see not much has changed. The paper might be neater, handwriting is neater, but the real essence of how the research data is recorded is still the same in an analog way in pen and paper. So in this respect, there's still a lot of room for improvement, especially if you consider that in industry, paper lab notebooks are very rarely seen these days. In industry, especially in the synthetic chemistry domain, it'll be hard to find a company that still works with paper lab notebooks. So the data that we deal with is data originating from molecules and their corresponding metadata. These can be molecular properties, how these might be described also in a machine readable way, such as the INCHI. Any spectra these data may generate, these can be NMR spectra, mass spectra, and then also very importantly, how do you assign these spectra in a machine readable way, and very importantly also in a machine searchable way. It could be how these compounds were made in the first place, so chemical reactions. How do you document chemical reactions in a machine readable way? How do you describe synthetic procedure in a machine readable way? Conditions, so it's all searchable as well. So there is a standard for how these things are described, and then any biological activity these molecules might have thereafter. So what's the status quo with these types of data in chemistry at the moment? The reality is a lot of it is very analog. Right? There is some digital data, but usually it just lives on people's personal devices or some hard drives or some institutional hard drive somewhere. There is plenty of digital data that comes from analytical devices, be it HPLCs or NMR machines that may end up on some institutional server somewhere. But the worst thing is actually how we publish this data. We take this digital data and we destroy all kinds of machine readable aspects of it by just converting it to a JPEG, and then we just dump it into a supporting information, and a lot of information gets lost there. And a picture of a spectrum is not much use to anyone really, because if they, let's say, if they want to make the compound again and they want to compare it with the compound they made, they're not able to do a direct overlay. And this is actually an example of where lots of costs are generated in the everyday chemistry research. So if I think back to when I was in the lab, I would routinely measure spectra of all my starting materials, right? So for each experiment, I would be doing 5 or 6 extra analyses that I would not have to do if these things were just available in the public domain. And these analyses aren't cheap, right? Because these machines, they cost a lot of money. They cost money to run. Staff have to maintain them. And if you think about that all around the world, if people don't have to analyze their starting materials all the time, it's actually a lot of money and resources that can be saved here. But nonetheless, I digress. This process is called unfair. So FAIR is an acronym for findable, accessible, interoperable, reusable. Findable so that you can find the data set according to an unambiguously assigned DOI. Accessible so the data set lives in a repository. Interoperable so that the data is not in some proprietary format that only software can open, that you have to pay money for and may even cease to exist at a certain time. And reusable, that the reuse of the data is clearly defined. And this is where we always like to stress that FAIR does not mean open. I know there are a lot of people from the research data management domain in here, but very common misconception among many chemists is that they hear fair and they actually think open. So they say, oh God, no, I don't want to work fair because it means everyone can access my data. It's very key to stress here that you can have fair data that is not open, right? And especially for, let's say, publications where you fear you may lose a competitive advantage if you make your data open immediately. There are ways such as putting an embargo on the data for 2 years or something like that, and then it's still fair, but it's not open. So what is our vision? How do we get away from this analog domain? The reality for chemistry is that it's very hard to make existing data fair retrospectively. I mean, there are fantastic efforts that are trying to achieve this by finding data from the 40s or 50s and see how we can make it machine readable. But if for your own workflows, the most realistic thing is actually that you work digital from the beginning, right? So here, the whole research data lifecycle has to be digitalized. And if you use electronic lab notebooks to help you in this endeavor, they can do a lot of things for you, so you don't have to think about them, right? So the ELN can take care of assigning the metadata. The ELN can take care of making sure that things are in the right format, as in open and not proprietary, so that when you actually come to publishing into a repository, the ELN has done a lot of these things for you, so you don't have to do them. Also applying the standards as necessary. So what is our strategy? So this is a general overview of what we do in NFDI for Chem. Is the top part is kind of the interface with the community. We have a help desk, we have knowledge bases, we provide various teaching and trainings. The middle is kind of the business end of research. This is where all the data is generated in the so-called smart lab, where ELNs interface directly with devices via APIs, and then everything in one seamless flow goes into repositories. And of course, for these, you need to define a lot of standards. Legal aspects need to be considered, and a lot of terminologies have to be written, and we're also involved in all these aspects. So let's start with the smart lab. So the challenge really is here: how do we actually get to fair data and make it as little effort as possible, because chemists are already incredibly busy. They're under a lot of pressure from the publish or perish paradigm, and so it's not reasonable to expect them to invest any more time than they originally already do. So ideally, the ELN should even save time here. So that is the challenge here. Let's just roll back briefly. What are actually the advantages of the ELN? So first and foremost, it avoids data loss, of course, if you've got an appropriate backup strategy, because it will be hard to lose your entire university's server system compared to a paper ELN that might be lost on the back of the bus at some point. But the key thing is here is actually that it links experimental data and experimental descriptions together, right? This is something that is not the case at the moment. People do the experiments in a paper lab notebook, and then the data lives somewhere else. And actually finding the two things together can be very difficult sometimes. You have the paper lab notebook, and then you have no idea where to find the data, right? It links them together, and it makes it findable immediately. Standardization is very important, right? So example, within a working group, everyone can understand each other's experiments, because the way the experiments are documented is in a standardized fashion. But not only that, it's also the way the metadata is assigned is also in a standardized fashion. This helps when with respect to the publication of the data. Knowledge management: the data is findable, right? Especially for predecessors. I've had to look for predecessors' data so many times, and only half the times I'd be able to find it, right? It can be a simple scenario as you go to your boss and say, well, where can I find this postdoc's data? And he says, well, it's somewhere in this room. You go into the room, many bookshelves, you don't know which bookshelf. First find the right shelf, find the right book, then the right page, and then even if you found the experiment, there's no guarantee that you'll actually find the corresponding data set, because you have no idea on which server it may be. So an ELN can save you a lot of pain here. And as I mentioned earlier, when it comes to publishing your data, the ELN really can save you a lot of time here because it does a lot of the work for you. Of course, there are a lot of ELNs available. Not one size fits all. There's not one ELN in chemistry that can cover all chemical subdisciplines appropriately. There are simple questions such as what are the costs, where's the data hosted, how's it accessed, who can actually look after the ELN, do I have staff to actually operate an ELN that is offered centrally, right? There is the ELN finder that can help you in this solution. We are going to talk about Chemotion today. Chemotion is the reference ELN of NFDI for Chem, and what we mean by that is that any new standards or tools that we develop, we try out in Chemotion first and foremost. So Chemotion itself is actually a holistic solution to research data management in that it covers the whole research data lifecycle. It has direct integration to data repositories, so it makes the publication aspect a little bit more easy. Some key facts about it: was developed by people at KIT in collaboration with people from NFDI for Chem. It's an ELN that was specifically designed for chemistry, and its main focus really is the realization of the fair data principles, and this is something that might set it apart from other ELNs, which may be more focused on the data organization within an organization and not necessarily outside of the organization. Some key advantages is it's open source, so it's free. It's browser based, so you don't have to install anything on your end devices. And many of the other things that are listed below on this slide, I will show in a live demo. So how does Chemotion work? It's usually installed on a server somewhere or on a virtual machine. This is then directly linked to a appropriate backup strategy. So in the academic context, these can be university backup servers. The ELN can ingest data directly from the devices. For certain types of data, it can convert them to open formats. You can actually control devices from the ELN via a VNC client, right? So if you wanted to, you could go on your phone, connect to your university VPN while you're in the pub and check on your HPLC that's running, and even check your traces to see what your EE is, because you can't wait until the next morning, for example. The users can access the ELN from any device, be it a tablet, phone, or computer. They just need a browser to access it, and they can actually analyze the data as well to a certain extent in the ELN, and don't actually need to go to another software for this. As I mentioned, the ELN has a direct link to repositories. So if you're in Germany, you can publish into Radar for Chem. In the next release, I think this will be integrated, but from anywhere around the world, anyone can use the Chemotion repository, and this is where you can then publish your data simply by pushing a button, really. Okay, so now I will switch to the live demo. I will go to the browser. I think everyone should be able to see that. Let's just get rid of the bookmarks bar. Okay, so this is what Chemotion looks like. You have various aspects, and we'll go through them. At the top right, you've got various things where you can change things. You could update your account here. You could change your password. So if we go into account and profile here, you can adjust things such as where your next reaction will be started. You can select your structure editor here. I'll be talking about structure editors in more detail in a little bit. You can, for example, say which research groups you belong to. There are no research group listed here because this is a demo instance that is behind a firewall. So this is not actually a Chemotion instance that is being used in active research. If I was using a Chemotion instance that was being used in active research, I would have to connect via a VPN, and then my connection to Pick the Button would be absolutely atrocious. So this is why I'm using a demo instance here. Okay, right. At the top here, you have various functions that will be going into more detail. You have a search box here. You have various little action buttons here. So this would be this little action button here would be moving something. This little action button will be deleting something, sharing something. This can is an export function. Here you can generate reports, and here you can do something with the circled elements. And as I said, we'll go into each thing in a little bit more details. Right, so the general hierarchy is that if you start from left to right, you are from a broad hierarchy to something a bit more, going from left broad to right to more detail. Over here, you have the so-called collections where various things can live, and then in the middle you see what are in these collections, and then on the right you would then see the detail of the individual things within the collection. Right. So I've mentioned the word collection a couple of times now. So what on earth are collections? So collections are just a very straightforward way of organizing your experiments in a hierarchical fashion, right? So if we just wanted to create a collection, we just click on the plus button, new collection, let's just call it a demo HeFDI, right? And then we click on save. We could then create a new collection called sub-collection, right? And then you can indent and outdent the hierarchy as you want. So it's very straightforward to do. Collections can be shared and synchronized among people. We'll show that in a bit more detail later. So if you create your own collections, only you can see them. They are only seen by you. Only because you're accessing this through the browser does not mean that they're somewhere on the web. You are the only person that can access these collections. You can share or synchronize. So share means you share a one-time state with someone, but you can also have synchronized collections. This, for example, if a research group works on a joint project, you can synchronize this collection. Define the rights, such as you can only read it, you can only write it, so people can't delete it, for example, and then people can have a joint collection, right? So, for example, for a joint chemical database, you could have this, right? So that's a handy thing to do. Okay, so much for collections. Let's go to the search function. You can search according to different things. You could search according to the name if you wanted to. The IUPAC name. You could search if a reaction is successful. Of course, that hasn't worked now. Far-field effect. You can search according to substructure, for example. Let's just draw an aniline moiety, for example. Let's just draw that. And it will spit out everything that has an aniline moiety. You can also search according to Inchy and Smiles codes. So let me just go to a document where I've copied some Smiles. So if I put in the Smiles here, we'll then also hopefully eventually spit out everything according to that Smiles code. Yep. So various things. The thing that the search function cannot do, it cannot search for things in an experimental description. So that is not part of the search function. Okay, so let's talk about elements. So elements are these things in the middle. As you can see, they're various tabs. We have an element that is called samples. We have an element that's called reactions. We have an element that is called research plan. And then there are some additional elements as well, namely screens and well plates. I won't be talking too much about screens and well plates today. These are more from a biological domain, and that is not the area I'm most familiar with. Okay, let's talk about samples. So samples are a way of documenting individual compounds. You need these compounds as well if you're doing reactions. So let's go to the collection we created early on, demo HeFDI, and let's just start creating a sample. You would click on this button above here. A new window would pop up, and then there are various ways of getting started. You could, of course, start by just drawing a molecule, right? So we could just draw the aniline again. Right. That would be one way of doing it. You could, let's just delete what we've drawn. Being a bit, where's the delete button? It's always different structure editors, I get confused. There we go. You can do fast create by putting in a CAS or a smiles. So let's just get a CAS number here. Let's put in a CAS, right? And then it would also find the aniline. And you can do the same thing for a smiles code, right? So there are fast ways of creating these things. In the structure editor that I just showed you, by default, there are two structure editors available, which is Catcher Rails and Catcher 2. These are both free structure editors as in open source. If you have licenses for them, you can also enable ChemDraw.js and ChemDraw, and also Marvin is available. Right? So you might be thinking, oh, well, I have all these huge molecules in ChemDraw, but I don't have ChemDraw.js. How do I get them across to Chemotion without having to redraw them from scratch? Well, there's also a way of doing that, in that you can just import something via a mol file. Okay, so let's input a mol file, for example. If you wanted to then add something as a mol file, it would then also create the aniline. So in ChemDraw, you can copy things directly as mol files. So even if you don't have ChemDraw.js, you don't have to reinvent the wheel. You can just copy things as a mol file and then input them into Chemotion that way. Okay, so then if it's a known substance, it would also suggest some names. You can select various things, right? Let me just have a look. You can include external labels. You can include various physical properties. If the compound is known, come on. It doesn't like being in full screen, apparently. If the compound is known, there will be a link to PubChem, right? So this is known in PubChem, and if you click on it, you can then also go across to PubChem. Samples are a way of also organizing things in an inventory. So at the moment, you can see things such as location, right? In the next version 1.70, there'll be a more sophisticated inventory function available, which will make this a bit more obsolete. Okay, you might be wondering about the naming of things. So how do I get my own name on these compounds? This is a common question because the ELN usually gives it a certain name. There's a way of toggling this. You could deselect this and play around with these things, and then it will show various ways of representing it. So this is the SG687 is what the ELN called it. But if you want your own external name on it, then you just click that, and then the name that you gave it will appear. So if you want to continue using your own numbering scheme and not the numbering scheme of the ELN, you can use this function and you'll still be able to see that. There is another important aspect to samples, which is the so-called decoupled mode. So let's just go back to the sample that we created. Which is this? So if you do a decoupled mode, this is a way of, so you can see here the molecular mass thing pops up. So if you've got molecules that aren't representable in a machine readable way by an Inchi or Smiles code, let's say it's a huge polymer or a some kind of protein complex or even a mixture of compounds or stock solution, whatever, you can select the decoupled mode, and that really enables you to still, well, you can basically draw anything for it. You can be a circle and a blob or something like that. And then you can still work with this in the ELN, right? So you would then just add the molecular mass, right? And then the picture would appear in the reaction screens that you then use thereafter, right? So it's a way of working with things that are not yet covered by HEL slides. Decoupled mode is not enabled by default, right? This is something the admins have to enable. So this is what the admin interface looks like. You can see I just switched to the incognito mode. The incognito mode from Google Chrome is actually a fantastic solution to enable multiple people on one computer to access Chemotion. So let's say, for example, you are in a lab. Let's say 4 people are working in one lab area. There's an HPLC computer there, and everybody wants to access the ELN from the HPLC computer. Obviously, if you in the normal browser tab, only one person can be logged in. But if everyone has an incognito tab open, everyone can be logged in simultaneously. So that's a neat way of being able to log into the ELN multiple times from one device. So I'm now logged into the ELN instance, both as a user and as an admin. So here, the admin interface, you would go to UI features, and you can see the sample decoupled mode here, and we can see it's not enabled globally, but it's enabled for 2 users specifically to do that. There are reasons why you don't want to enable the decoupled mode. Especially when people are starting to get used to the ELN, you actually want to encourage them to represent everything in a machine readable way as much as possible. But there are obviously very good reasons to enable the decoupled mode, because lots of people work with molecules that are just not representable in a machine readable way. Okay, so now I've talked about the decoupled mode. There's an analyses tab. We'll go to let's go to a sample that actually has some analyses in them. That sample looks good. I'll go to here. Yep. So analyses can be found here. I'll talk about analyses in a bit more detail when we cover the reactions. There you have references here, so you can reference various papers. QC and creation is a very handy feature, because it can tell you what data is available, what data is not available. To a certain extent, the ELN is able to do some quality control on this data. So in the case of NMR spectroscopy, it will do a simple proton or carbon count and tell you, I'm expecting 20 protons, you've got 21 protons, a better check, or I'm expecting 20 carbons, there are only 19 in the spectrum, better check. And this happens a lot, of course, because sometimes the signals overlap or you have symmetry, and then the ELN can help you find easy mistakes, right? But this is not a, let's say, a substitution for a complete quality control by a human. Okay, and yeah, so that's so much for the samples. Let's go to reactions. So let's just open a reaction that's already been done. It really isn't the fastest today, the instance. I apologize for that. Let's go to a chemical reaction. So here you have a reaction scheme, you have stoichiometry tables, various things that are down below. And actually, the reaction scheme is populated directly from what is added below. This is not just something that someone has drawn. So if I go to the reactions conditions, for example, and I added, let's say, coffee, the word coffee would appear below the reaction arrow. Right, so this is generated directly from the thing. Okay, so let's just create a reaction. Let's go to the collection we went to earlier on. We create a new reaction, and the key thing is here, you don't need to draw all the starting materials again. You can just go to, let's say, your samples, and then I drag in, let's say, the starting material. I mean, this is not going to make any sense chemically whatsoever, but well, go on. And then you could also add reagents, right? And you could add the product, even though this is not the product. Let's just drag it in for demonstration's sake. And so again, simple drag and drop, very easy way of creating the reactions. If you wanted to start a new reaction that was similar to one that you've done before, or want to do the same reaction again, there's also a very easy way of doing that. You would go to the reaction, click it, and then you would go on copy reaction, and then a new reaction window opens that you can save wherever, and then you don't have to reinvent the wheel, right? So especially, let's say you've got a project where you have a starting material that takes 5 steps to make. You have to go back and make all of these starting materials. You don't have to write out every single experiment again. You can just copy those reactions and then just do them again. But again, then each new reaction has its own unique identifier and unique analyses that go along with it. Okay, let's go back to a reaction that looks reasonably well completed. Definitely not that one. And have a look what there is. So we have the various functions here. So if something was a very large molecule, and I think I have a reaction down below here. If I'm not mistaken, where there is a very large molecule where this could be demonstrated. Yeah. So here you can see this catalyst is a bit large, and it's not making the thing very useful to look at. You could click on the switch to label function, and then it will switch to the label and make everything a bit more readable. So that's kind of a handy feature. Let's go back to this one. This T here stands for theoretical and actual, right? So often you say, I want to add exactly 7,170 milligrams to the reaction, but it might not necessarily always be possible to add exactly that amount, especially if you're working with something that is extremely hygroscopic and just sticks to everything. There's a way of then recording the amount that you actually added, and the ELN will then calculate your yields based on the actual amounts rather than theoretical amounts. If you change one thing in this stoichiometry, it will automatically update. So let's just add 2 here. All the amounts will automatically update. So that's a neat way of just changing things. You can select from a vast range of solvents. You can give it another name. This is a really neat feature. Status, especially for people that are looking at your lab book later. So I've looked through many paper lab notebooks, and I've came across experiments. I was like, has this experiment actually been done or not? Right. So this is a way of indicating I'm planning this experiment. I'm in the process of doing it. I've done it. All the analyses are pending, or it was successful, or it was not successful. So this is a really neat feature of indicating these things. You can not only say what temperature it was, but you can also create temperature graphs. So you could say on temperature gradients, you could let's say start at 25, then go to 60, go to 70, right? Need to change the times a bit as well. 10, 30, So it's a way of recording temperature profiles as well. So that's something that can be quite handy. Right, okay, so here, simple temperature profile. Start and stop times. At the moment, in the current version of Chemotion, there is not an audit trail, so these things could be changed retrospectively. We have developed an audit trail, which is just a simple version control, so you could retrospectively see the changes. The audit trail should hopefully be implemented by the end of the summer, by the looks of the development timeline. We have got it working in test instances, but the deployment also depends on what kind of major bugs we encounter where we do the next releases as well. So hopefully it's the end of summer, but if it might be a little earlier or a little later, depending on what kind of bugs we have to fix in the medium term. Ontology, as most people don't select as much as they should, despite it actually being very useful, because if you are searching for, let's say, the Chemotion repository later for types of reactions, if the reaction has been included in the ontology, it makes it a bit more findable. So, for example, I'm looking for all Vitic reactions. If you've defined that in the ontology, it can be found a lot easier. You can also define if it's a single reaction, if this reaction is a general procedure or part of a general procedure. These reaction descriptions are quite useful as well. You don't have to write them out from scratch every time, so let's just delete whatever's here. If I click on one of these buttons, a text will autofill, right? I don't even have to put in the amounts. I could just go to the table above, click on it, and then the amounts would be split into the table below. So it's a very quick way of writing these things. These buttons can be customized, so you can see I can see which buttons I want to see and which not. And the text of these buttons can also be customized on the admin interface. You would go to text templates, and here you can basically select anything you want and then just change the text. So it's a very neat way of building up templates for various things. Okay, let's go back to the ELN. And I'm just checking that I've said everything I need to say. Okay. You can select various methods of purifications. You can have additional details, and then also you have private notes, something that I personally find very useful because I have many instances where a yield may have been a little lower because I dropped the reaction vessel on the floor. I had to do a paper towel extraction, and then the yield was a bit lower. And of course, you might want to include the note somewhere. Yield was low due to a paper towel extraction, right? And then everyone knows, okay, this is why the yield was low, and not because reaction worked badly, but it's in a private note. So yeah, can be quite handy. Okay, let's have a look at how you could move a reaction. You could also move a reaction, for example, just by selecting it, move to a different collection or assign to a different collection. That is also quite useful. Let's look at some of the other segments. So segments is the name in Chemotion for different tabs. So the properties tabs, various things that you already saw on the previous tab, you could select, but then also you could, for example, include HPLC details. Analyses. Now, this is a very important part. In principle, you can you can include all types of analyses in Chemotion, right? You can upload anything that you want in principle. So if you wanted to add an analysis, you would click on it, right? You can could see if you can find it in the chemical methods ontology. So you could search for NMR. So you could then search for NMR, so it knows how to deal with it, for example. But in principle, you can add anything you want just by dragging and dropping, right? So if you have data sets that the ELN can't interpret, you can still document them with the ELN. Or if a data set is so huge that it's that you don't want to include it on the ELN server because it's, let's say, a terabyte or two. It doesn't make sense to include a terabyte or two on the ELN because no one would routinely download the whole terabyte. You could then just reference where it's kept via hyperlink to a repository or to a file path, for example. Right? For specific types of data, the ELN is actually able to interpret it, right? So, for example, for NMR data, it is able to interpret it, and you can analyze it in the ELN if you wanted to. So this is ChemSpectra. This is a browser-based analysis tool. So this is interactive. You can do integration and all the things. It will generate the peak lists. You don't have to if you don't want to, of course. You could still use Mestranova and then just transfer the peak lists across. But this is actually really handy if, for example, if you're working in a teaching lab context, because the students do everything in one window. They plan the experiment, they get the data into the ELN, they analyze the data of the ELN, and then they generate the report from the ELN as well. And I'll show you what a report generation looks like in just a sec. ChemSpectra is able to do the usual suspects of NMR, IR, mass spec. For NMR, there's an additional tool available, not yet in this version. So at the moment on my demo instance, I've got 1.41. As of 1.5, you also have the opportunity to include NMarium. So I've opened NMarium in another tab here. This is a more sophisticated browser-based analysis tool for NMR data. It has a little bit more functionality than ChemSpectra. And we also are working on enabling the 2D analyses features of NMarium as well. So that should hopefully be available soon as well. Okay. Okay. You can also link devices directly to the ELN, right, as I mentioned before. And if you then if the NMR runs, you would then receive your spectrum in the inbox, and then you just drag and drop it across. But if you don't have devices connected, it's still not a problem. You can still just manually drag and drop it into the analyses as I just showed. Okay, let's say you run a bunch of reactions and you want to write a subinfo, for example, for a paper. Right? Come on. And you want to generate a report. You could select various reactions, right? Let's just tick them. I apologize, the testing instance is being a bit slow today. I would click on generate report, and here you could select from various templates, so be it supporting information. You can adjust various settings of what you want to include. You could adjust the order. So say you want this reaction first, that reaction first. You can give each compound labels, right? So you'd say you want that compound to be O1, that one to be O2, or whatever you want to label them. It gives you a preview, and then you would click on generate. Especially considering it's being a bit slower today, it might take a while to generate. But here's one I prepared earlier to quote pretty much every cooking show there ever was. This is what is spit out. It's a Word document, right? And so this was generated directly from the ELN. And these are actually ChemDraw files as well, so you can edit these structures in ChemDraw. And as you can see, I think for some of them, I included the numbering as well. So here, for example, here the numbering was included. Do we have formats for every journal? No, but it's certainly quicker to take this output and put it into the Angevadge or the JAX format, for example, rather than writing everything from scratch. If you want to include your spectra in the SI as well, you can also just select the spectra template. And then it will automatically compile the spectral part of the SI as well, including all the depictions of the data. And the neat thing is here also that if you have pictures directly from the spectrometer, you can include these as well, rather than the one that are generated from ChemSpectra. So, for example, here. Okay. So this is the report function. So that can definitely save you a lot of time when you are writing a. Oh, so it's just finished, as you see. It can save you a lot of time when you're writing sub-info or your experimental part for your thesis. I really wish I had this when I was writing papers or thesis. It would have saved me a hell of a lot of time. And I'd say one of the major advantages of this function is that it eliminates a lot of human error sources. So when you're writing sub-info, you're doing a lot of copy and pasting from, let's say, from Mestron over to the supporting info, and it happens so quickly that you copy the wrong data across for a compound. The ELN basically entirely eliminates this human source of error, and therefore also the amount of time that you have to invest for the quality control of that source of error, because you don't have to look for the copy and paste error if there isn't one there in the first place. Okay, let's say you want to share your data in Chemotion. There is a way of sharing it internally, as I just mentioned, with the synchronizing aspect, right? Here you can have various rights that can be defined. So there are presets. So everything, a user will have a preset, a partner will have a preset, a collaborator can have a preset, but then you can also define these specifically however you want to. It's very important to consider these things within a research group, because you don't want a bachelor student, for example, to be able to delete the entire research group's collection. And you don't need to reinvent the wheel here. We have we published a paper called Sharing is Caring, and here basically we really show an example of how it can be done. It's a traffic light system for various roles. So PhD student can do this but can't do that. PI can do everything. Bachelor student can pretty much do nothing to certain things. So so he's down here, has very little access to, for specific things. So you don't have to reinvent the wheel, and you can just look at things here. Especially if you're worried about someone deleting an entire collection, this can be adjusted with that. Okay, if you want to share stuff externally from Chemotion, you can. This is also possible without publishing it by just doing an export. So you could export a collection, right? This would generate a zip folder. This zip folder can then be imported by another Chemotion user and another institution, and then they will have the entire collection very easily. Let's have a look at the research plan. So the research plan is one way of flexibly documenting, let's say, more overarching thoughts. So let's just create a research plan. You can add text fields where you can write various things. You can have tables where things can be documented. You can delete, add columns as you want. You could add pictures. You could add catchers. So if I click on this, I could add a chemical structure. You can. That's really performing a bit slow today. Apologies for that. Let's just reload it. If not, I'll go into another instance. You can also drag and drop samples across. So I've added a sample field here. I could then just drag a sample in, right? And then that would appear. Or if you have a reaction here, you can drag that across. This could be quite useful for documenting overarching thoughts. So I think here I wrote a research plan for a reaction screen. So someone is optimizing a reaction and they want to have a look at, for example, one specific parameter in ER. A general reaction was created, drag and dropped in, the R was looked at, and then various things. Although I should say for this specific function, an additional function for the reaction feature will be available where you can just vary specific parameters. But this is just one example for the research plan. Analyses can be included as well. Attachments as well. You can also include Excel files, and if you have only Office enabled at your institution, you can also edit those Excel files, for example, directly in the ELN without having to constantly upload them and download them. I'm just having a look at time. I will skip the well plates and the screens, and we will go to the publishing aspect. If you wanted to publish your data, you could go to the Chemotion repository. So this is what the Chemotion repository looks like. You can go to the normal repo overview. So this is where various reactions that have been done have been published. You click on a reaction, every reaction has a DOI, every analysis has a DOI, and you can look at previews from the data, but also you could go into ChemSpectra in the repository as well. So this you guys can already access. You don't need Chemotion enabled at your end. You could download the data. If you sign into the repository, and again, this doesn't cost anything, anyone can create an account and just sign in. You go into the ELN interface of the repository, and the neat thing here is that you can actually interface with all published reactions in the Chemotion repository as if you were in the ELN yourself. So let's just go on something here. This was a reaction someone published somewhere, and I can see exactly how it was done, the descriptions. I can go to the analyses as well. I can download the analyses there as well, so it's really quite straightforward. You can then link your ELN to the Chemotion repository, and then if you go in the ELN gate, those reactions that you decided to publish from the ELN will then appear here. If you wanted to publish them, they will then go through a quality control process, and then after review, they can then be published in the repository. So this is a really neat feature. If you wanted to publish just a compound, if you don't even have the ELN, you could create an account with the Chemotion repository, create a sample, and then you could do it even without the ELN, right? So this is also a way of people, a way for people publishing compound and reaction data without having to use the ELN. And as I mentioned, this kind of integration that you just see now will also soon be available for Radar for Chem, which is a repository for, let's say, for those types of data that don't necessarily fit into the Chemotion repository. So a lot of the stuff that you've just seen was very synthesis-based. Not every chemist is a synthetic chemist. And this is where lab by motion, or the generic elements of Chemotion, come in. And here we try to make the ELN as interdisciplinary as possible. So let's look at a generic element. So this is an element that a user created themselves, right? So this is something a user created. Let's just switch to the admin interface briefly, go to the generic elements. So this is the element that we just saw. You can, all these drop downs and fields that you just saw can be added, can be customized. We usually do whole demos just on the generic elements themselves, because they are. It takes some time to understand them and to use them appropriately. But just be aware that you can basically recreate your own workflows using the generic elements. We have an instance here, for example, where all the generic elements have been included. Defined workflows can be created. So, for example, if you're doing something according to an SOP, and one thing has to follow the other. So, for example, here you do something, and then you would select cutting, and then you would fill out these details, and then you would have to do the next step, which is embedding. And then there are two options of what you could do according to the SOP, and then you can select it. So you can also select these specific workflows. If we then go to the generic designer, we would then look at, let me just look what it was called. Yep, I think it was down here. Where is it? Yeah, here we go. So if this button is here, it means there's a workflow that has been defined. And you could see the workflow. You have a workflow overview here. You would have to do that. You would have to do that. This would then have to follow, and then there are diverging paths. So it's a way of creating these workflows in Chemotion. The copying workflows from one instance to another instance is not that hard to do, actually. You would just go to this YAML editor. I have no idea what any of this means. I'm not a programmer, but I know if I highlight all of this text, copy it, and paste it into my own instance, I will have this generic element, right? And this is where I will go back to the slides, because our future plan with the generic elements is that we will. Oh, I went to the wrong part of the presentation here. Let's see if I can get that up. Okay, so I blanked these out even though I did not want to. Bear with me a second. Did not need to do that. Okay, so the idea is that you can publish your generic elements in the Chemotion repository. So you don't have to reinvent the wheel. You can look at what templates there are available, and then more importantly, you can then also publish the data that has been generated by the generic elements also in the Chemotion repository. New features that are coming soon is so since 1.5, you can also log in via Shibboleth, right? So your university credential management system, image annotation tool is available. Things that are on the pipeline are, as I mentioned, the audit trail. You'll be able to view CIF files. The inventory functions will be there. Multi-reaction planning, that's what I alluded to with the screening aspect of things, and then the NMRE and 2D support. How do I get Chemotion? How do I get started with it? So the first thing is you'd contact the help desk. We would then organize a demo, pretty much what I've just done now, followed by some Q&A. Then we would provide a free testing instance for 2 months, so you don't have to go through the trouble of installing it. You can evaluate whether it's suitable for you on the testing instance. This is hosted at KRT, so we can't make any guarantees for the data there. And then if you do decide to install it, we can help you with the installation process and then provide continuous technical and user support, such as trainings and workshops. There's a comprehensive online handbook where you can look at various aspects regarding the installation and also the operation of the ELN. There are various introductory videos and in-depth videos. There's a YouTube channel where various useful videos are. We will have a hands-on workshop on the 27th of July. It's a 6-hour workshop where you get introduced to the basic features of the ELN by learning by doing approach. I mentioned the help desk. This is where you contact for any questions regarding Chemotion. And I think in the interest of time, I will skip the other NFDI for Chem services, so there's time for questions. And I'll thank you for your attention. Please follow us on our usual suspects on social media. And yeah. Oh, I have to show this slide because this is something we were very happy about. We had our chemistry data days in Mainz last week. Really happy to see about 100 people there. It was a great day with people not just from the research data management bubble, but also users from all around the country that came to learn about NFDI for Chem and its services. So thank you for your attention. Happy to take some questions.